Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about classical definition of probability. So in exam point of view, sometimes they are asking this classical definition of the probability, sometimes they are asking interpretation of probability. If there are capital N exactive, so capital N is the total number of possible outcomes, N suffix A is the number of favorable outcomes. If there are capital N exactive, mutually exclusive and equally likely events, out of which N suffix A events are favorable to happening on a happening of an event capital A. Once again, if there are capital N exactive events, mutually exclusive events, and equally likely events, out of which N suffix A events are favorable to the happening of an event capital A, then the probability of event capital A is given by or defined as probability of A is equal to N suffix A divided by N, where N suffix A is the number of favorable outcome of the experiment and capital N is the total number of possible outcomes of the experiment. So this probability of A is also now, uh, is also known as probability of success of an event. This probability of A is also known as probability of success event A. So in this experiment, N suffix A results are favorable to event capital A, and hence the remaining capital N minus N suffix A. Capital N is the number of total events of the experiment and N suffix A is the number of favorable events with respect to event A. Okay, and the remaining experiments mean that are capital N minus N suffix A results are not favorable to the event capital A. This set of unfavorable events are denoted by symbolically A bar or A cap, A bar or A dash or A cap. So therefore, the probability of unfavorable events, probability of A bar is equal N minus NA divided by N. So N minus NA is the unfavorable events and capital N is the total number of outcome of the experiment, number of total events of the experiment. So therefore, so now we are on RHS side. This RHS term is written as capital N divided by N minus N by NA. So first term capital N is the cancel 1 minus in the second term RHS side the second term is the probability of the event, that is the probability of the success of the event, probability of A. So this probability of A is coming to the LHS side. We have probability of A plus probability of A bar is equal to 1. From this equation, we can conclude that generally the probability of success and the probability of failure is equal to 1. Probability of success plus probability of failure is equal to 1. So now here what is the probability of the success? P of A is the probability of the success of the event. Probability of A bar is the probability of the failure of the event. So generally the probability of the success is denoted by P and the probability of the failure is denoted by Q. So therefore P plus Q is equal to 1. P is the probability of the success, Q is the probability of the failure. The summation of the probability of the success plus probability of the failure is always equal to 1. So the probability of the success P is equal to or P of A is equal to NA by N and the range of the probability of the success is 0 to 1 and probability of the failure P of A bar is equal N minus NA bar by N and where Q is equal to 0 to 1. So if probability of A is equal to 1, event capital A is called a certain event or sure event. So clearly capital S or capital U is a certain event or sure event since the probability of S is equal to 1.
If probability of A is equal to 0, then the event capital A is called an impossible event. Clearly, pi is an impossible event since probability of pi is equal to 0. So these two are the very important points. Keep in mind. Probability of S is equal to 1. Probability of impossible event, probability of pi is equal to 0. So the good example of the classical definition of the probability, consider any one example. Here I am considering, for example, when a pair coin is tossed, the possible outcomes are 2. When a pair coin is tossed, the possible outcome of the experiments are 2. There are 2 outcomes of that experiment. If the event capital A is a show heads, event capital A is a show head. So tossing a single coin, the possible outcome of the experiment of head is 1 chance, and total number of the experiments are 2. So therefore, then the favorable outcome is 1. Hence, the probability of A is equal to 1 by 2. And one more example. Similarly, when a die is thrown, the possible outcomes are 6. That are 1 to 6, 1, 2, 3, 4, 5, 6. If the event A is show odd number, so find the probability of the event show an odd number in that experiment. And what is that experiment? Rolling a die. And what are the odd numbers? The odd numbers are 1, 3, 5. So the favorable outcomes are 3. So therefore, the probability of A is equal to favorable outcomes by total outcomes. The total outcomes are 6 and the favorable outcomes. And what are the favorable outcomes? Probability of show odd numbers. So how many odd numbers are showing in that experiment? 3. So therefore 3 by 6 is equal to 1 by 2. So these are the examples of classical definition of probability. And there are some limitations of classical definition of probability, that are, first one is the elementary event must be equally likely. And the second drawback is the sample space must be finite, but in some experiments the sample space is infinite. So these are the some disadvantages, some limitations of the classical definition of the probability.